All right, good morning, guys. I hope you're doing well today and staying warm. Yeah, that cold streak has hit. I heard it was, yeah, like high of 20s or something like that, and snow in the forecast. Ugh. We don't have any snow yet, though, so crossing my fingers it holds off a little bit longer because I'm definitely not ready for that. All right. I don't really have any announcements for you guys today, which is kind of unusual. Don't forget the Unit 3 test is assigned for this week, so get that turned in at least before that Sunday deadline. Some of you have already taken it, and the scores are amazing. So that test is going really, really well for you guys, or at least for the people who have taken it. I kind of predicted that just based off of what I saw in the review game in Tuesday's class. So that was nice to see that you guys are definitely on track with your exponential and logarithmic functions there. We are switching gears a little bit, and we are turning to trig, woohoo, in Unit 4 and Unit 5 to kind of wrap up the rest of the semester. So the next couple months here, technically 2 months, I guess, we'll really be looking at a lot of trigonometry. And today starts our adventure. Woohoo! Um, in Unit 3 or Unit 4 here, you will be introduced to something called the unit circle. I want to say lesson 3 has the unit circle in it. It's going to be really handy if you can print that unit circle off. If you can't, definitely at least put it in your Google Drive folder so you can have access to that at all times. But if you have a printer handy for you, like to you, I would really recommend printing off the unit circle when it makes its appearance in lesson 3. Okay, moving forward though, today we are just taking our first look at our trigonometry, and trigonometry obviously is our sine, cosine, tangent, and their reciprocal functions. But before we get to those, we've got to actually talk about like the units of measure that we use when we're talking about trig. There are two units of measure that we can use when we're looking at trigonometry. We can use degrees or we can use radians. And we will kind of flip-flop back and forth between those two units of measure. So it's going to be really important that we pay close attention to what we're working in. Are we working in degrees or are we working in radians? Because that will decide whether we get the correct answer or not. Now, if you have your graphing calculator, the good news is that your graphing calculator works in both of these units of measure. So your calculator is actually set up to work in the radian right now. So if you go to mode on your graphing calculator, so if you hit that mode button, which is right next to the second feature, so if you hit that, you're going to notice that the third line down, you have radian selected already. Okay, so we've been working kind of in radians up until this point. We can use the over arrow and then enter to make sure that that is highlighted and flashing now. So if we need to change to degree mode, that is where we would do it. So in your calculator, you're going to get really, really familiar with this button, that mode button, so that you can switch between the two. So if you're working with degrees, and we all know what degrees look like, right? The little notation there for the degree symbol. That's our signal that we're working in degrees, and we need to switch to degree mode if necessary. And if you have pi, so pi is the big indicator that you're working in radians. So if you're working in radians, you'd have to shift over to that radian mode. So again, I already did that when I set it down. I put it back to radians. But you would need to keep kind of moving back and forth between the two. So That's a brief introduction there. Something that we're going to get really, really used to and working with our calculators is switching between the two modes. All right, when we talk about trigonometry, in the past we've always set up right triangles to identify the sine, cosine, and tangent to a certain angle. The angle that we are comparing that to is what we call the central angle. That's denoted with your theta. So this little marking right here is our theta. That's how we set up our trig functions. So we look at theta and we ask ourselves, okay, to set up sine, what would be opposite over hypotenuse, that kind of stuff. We don't need to get that in detailed yet. That's coming up. So the actual sine, cosine, and tangent stuff is coming up in the future. But for today's purpose, we just need to recognize that, yes, we are working with right triangles in trigonometry, and theta is what we call that central angle. Today, we are going to be working between degrees and radians. So degree is obviously that unit of angular measure. And we can also break down our degrees to be a little bit more exact. We haven't really seen this in the past, but when we have degrees, we usually just work with the whole number, right? But we can actually break it down smaller than that. So we can break it down into minutes and seconds as well. So here you'll notice that we have 24 minutes, 36 seconds. So 42 degrees, 24 minutes, 36 seconds. So we actually break that down into a more exact measurement by using minutes and seconds as well. Notice the one little marking here is denoting your minutes, and the two little markings denotes your seconds. Now, degree, minutes, seconds, so breaking it down to that really precise measurement is, we have an acronym for that. So if you see the DMS measurement, so DMS is referring to degrees, minutes, and seconds. They want you to transform that into degrees, minutes, and seconds. So for example, let's convert the 37.425 degrees to write that as degrees, minutes, and seconds instead. So the good news is the degrees is already there for you. It's that whole number that's out in front of the decimal. So it's the 37. We need to find the minutes and seconds piece to that. So I'm going to just put the 37 degrees. Now to find the minutes and seconds, it's really not that bad. You're going to take the decimal point of 0.425 and we're going to multiply by 60. Now, why do you think we're multiplying by 60? Where does that come from? Yeah, basically 60 minutes in an hour, right? So you're thinking about a whole, and you have that 60 minutes in 1 hour. So that's what we're going to start off with to find the minutes. So we're going to multiply by 60 to break that down into minutes. What is 0.425 times 60? Who can tell me what that is real quick? A 25.5. Good. So we end up with a decimal here, which is okay. The 25, which is that whole number kind of out in front, that is going to represent the minutes that you have. So right now we're sitting at 37 degrees, 25 minutes. We have to take the decimal from that response, and we're going to multiply by 60 again to figure out how many seconds there are. Now, why am I multiplying by 60 again to figure out the seconds part? Because there's 60 seconds in a minute. Awesome. We have to remember those calculations for part B coming up in a moment here. But let's go ahead and multiply that by 60 again. 0.5 times 60 should be our 30, right? Half of 60 is 30. So we converted that to 37 degrees, 25 minutes, 30 seconds. All right, questions with part A. Okay, part B is going the other way around now. So if I have that degree, minutes, seconds, can I convert that to a decimal degree? So like what I have written in kind of part A there. And we can, yep. So to do that, what we are going to do is take the 42 and add on each of these fractions then. So I'm going to take 24 and make that a fraction by putting it over 60. But I need to be a little bit more careful when I create this last fraction for the minutes. All right, or for the seconds, I mean, sorry. When I'm talking about seconds, my denominator is not going to be 60 anymore. What do you think it's going to be? Close. Add another 0 to it. 3600. Now 3600 comes into play because we are comparing it to the hour, right? There are 3600 seconds in an hour. So we got to keep the unit of measure the same between the two fractions. So if we're comparing it to the hour, we've got to make that into 3600 seconds. Good. So that's the only kind of tricky part that you have to remember with setting up that last fraction for the seconds there. Now, you do need a calculator to figure this out. So let's just type in 42 plus 24 divided by 60 plus 36 divided by 3600. So I just plug that in real fast using parentheses around each fraction. And let's see what we get. It should give you a decimal response. 42.41. Yep, and we expected that 42 to be out front, right? That the degree part wasn't going to change. The only thing that was changing was the minutes and seconds are being converted to an actual decimal answer. Okay, any questions with that? Okay, that's kind of topic 1 for today's lesson. There are kind of 3 topics that we're going to look at. So that's topic 1. Topic 2, oh, we're not technically, this isn't the second topic, but I just want to let you know that as we're working with these trigonometry, we use it a lot for bearings. So when we get to the story problems, you're going to see a lot of the degree measures and maybe even the DMS format with bearings. So navigation and all that good stuff. So we probably won't see that in today's lesson, but if you're wondering what the purpose of it is, that's the purpose. And we will see some of these moving forward with our trig unit. So we won't see it today, but heads up, it's in the future with these story problems, and we're talking about bearings and measurement. Hey, better to recognize that now than never, right? Better late than never. It's all good. It's all good. Now it all makes sense, right? All right, the second topic for today's class is converting between the two measurements. So can I convert from degrees to radians and vice versa? And the answer is yes, and it is quite easy as well. You just have to multiply by a ratio. So what ratio are you multiplying by? You're going to be multiplying by the ratio of 180 degrees over pi radians or vice versa, depending on what you want to convert to. So how I always remember it is I just remember the 180 in pi. And when I go to set up this problem to convert, I always am asking myself, what do I want to cancel out? Because that's going to help me set up the ratio that I want to use in that problem. So for example, in part A, how many radians are in 90 degrees? So you're starting out with 90 degrees. In order for the degrees to cancel out, does it go in the numerator or the denominator of that second ratio? So if you want the degrees to cancel out, it has to go in the denominator. So I know the degrees in the ratio is 180. So that would go in the bottom, and the pi would then go in the top. So as I'm going through these, when I try to remember what I should be multiplying by, is I always ask myself what's going to cancel out. What do I want to cancel out there? Okay, and that's how I set up that ratio then. All right, and now it just becomes a simplification type problem. We multiply across, so 90 pi over the 180. Notice the degrees are gone, right? Those canceled out. And then we simplify the 90 over 180. What does that simplify to? 1/2. Yep. Good. Okay, let's go the other way around now. So if I'm starting with the radians of pi over 3, I want that pi to disappear, right? So the pi has to go in the denominator because I want that to cancel out. So I know that the pi goes in the bottom, 180 goes in the top, and then you can cancel that out, look to see what you're left with, and simplify from there. What is 180 divided by 3? 60. And make sure that technically I need the little degree marking here on the 180. So 60 degrees is that conversion. So not too bad. You just got to kind of ask yourself that question, what do I want to cancel out? Because that will help you set up that second ratio that you need to multiply by. Okay, any questions with that? So that was concept number 2. No, leave it as pi over 2. That's a great question. Should we change that to a decimal? No. As we're working with trigonometry, we want to leave things in terms of pi. Yep, because that's a more exact answer than the decimal version of it. So we definitely want to leave things in terms of pi. So great question, because we are used to converting things to decimals a lot. So this is probably one of those times that we don't want to. We're going to leave it as a fraction. Okay, concept number 3 is dealing with arc length. Now there are 2 different formulas that you're going to use depending on what unit of measure you're working in. If you're working in radians, we use this formula right here. So S is the length of the arc, right? So S equals your radius times your central angle theta, which is in degrees. Or in radians, sorry. Almost made a mistake there. So that's what we want to use if we're working in radians. If we're working in degrees, we want to essentially use that same formula, but you're going to notice the conversion ratio in there as well, the pi over 180. That pi over 180 is going to convert that answer back into the radian measure of it. So if you're working with degrees, you can use that second formula, or you can go ahead and take that degrees, convert it to radians first, and use the top one. So a couple options there. You can actually use that formula that they have listed there, or change it back into radians and use that S equals R times theta. Okay, so this is concept number 3. I have a whole slide with practice problems for it coming up here. When you have that written down, go ahead, give me the green check mark so that I know it's okay to advance to some of those practice problems. All right, so I believe this is actually found in your book as well. We're going to go ahead and fill in the chart. We'll do a couple of them together, and then I'll let you guys fill in the rest of them there. All right, so notice you got S, R, and theta. And then you have a question mark in certain spots for these, and we got to answer what the question mark is going to be. Now, I'm going to go ahead and write down the two formulas that I just told you to copy down. If you're working in radians, you're using arc length equals your radius times your theta. If you are working in degrees, you've got basically that same thing, r times theta, but the additional piece of pi over 180 to change that back to a radian answer. So let's go ahead and work in, find out this first question mark. All right, so if I'm trying to find this first question mark, it is S. First of all, we have to decide which formula am I using. Is my units of measure in degrees or is my units of measure in radians? It's in radians, right? Because it says RAD. So that just tells you that you're in radians. Okay, so we can use the very first formula to help us there. Arc length equals your radius of 2 times theta, which is 25. So 2 times 25 should give us a 50 inches, it looks like, because that is what we're working in for the radius there. So 50 inches for the arc length of that circle, or part of that circle, I should say. All right, questions how we did that first one? Okay, then I'm going to let you guys fill in a couple more of the question marks. When we get to the theta, I'm combining my theta and radians there, creating a new term for us. But when we get to the theta here, because you're not given technically the unit of measure, I will accept it in either radians or degrees. So most common though is to see it in the form of radians. So just letting you know, you should probably use the radians for the theta out here. All right, be careful with the last two. You do need to convert these at some point. All right, I'll give you some time. Find those question marks. When you have an answer for a question mark, go ahead and put it on the board. All right, let's take a look at some of these responses. I'm going to start with, first of all, the second one, a 70. That one looks good. So this one is awesome. Down here, these two look good as well. I want to touch base on some of the other ones though. So let's start with that third row. So I noticed that we are working in radians, so I do want to use that first formula. I'm given S as 1.5. I don't know what R is, but I am given theta of pi over 4. So I like that you're multiplying both sides by 4, and I think that's where the 6 came from. But you still have a pi involved in your answer. So you do need to divide both sides by pi. So instead of having 6, you should have 6 divided by pi for that radius. And the same thing with the next one. You should get 7.5, I think, but 7.5 divided by pi still. Because you can't just lose the pi in the problem. It's got, pi is a constant, so you do want to divide by that as well. And I didn't mean to cross off the feet. I probably should just write that as over pi instead. There we go. Are there questions with that third and fourth row on how we found the r's here? So don't forget to divide by the pi in those. All right, let's take a look at this line down here. We are working in degrees, so we can use the second formula, or you can convert it first and then use the first formula. I'm just going to use the second formula for right now, so we're going to get 40 equals pi times the radius, which we're trying to find, times the 20 degrees over 180. Now, notice the degrees are going to cancel each other out from that formula. I can reduce 20 over 180, or you can just divide by it later on, however, whatever your preference is. I guess I'll just divide by it later on. So I'll start by multiplying 40 times 180 to get the 7,200. And then I'll divide by that 20. And technically you can divide by 20 pi right away. So 7,200 divided by 20 is 360, it looks like. So I think we're just missing a 0 from that response up there. Okay, so that one looks better. And then let's take a look at the last one. We're trying to find S this time around. I'm running out of space. Let's see. I'm going to use the second formula because I am working in degrees again. So pi times 5 times 18, all divided by 180. Technically, the degrees have canceled now. So 5 times 18 is 90, right? 90 pi. There you go. Awesome. Over 180 is pi over 2. Because we don't really have a pi in any of the other measurements, you could go ahead and put that as a decimal if you really wanted to. So that's going to be about 1.57 feet, it looks like. This is the exact answer though. So there's nothing wrong with leaving pi in there. But if you wanted to convert it to match some of the other ones, that would be about 1.57 feet. Okay, good. Any questions with how we filled in the table there? Okay, so good news is that was the third topic for the lesson. So we've reached all of the new topics that we needed to talk about. So now we're going to kind of backtrack and just practice those three topics. Obviously, we got a lot of practice here because there were a lot of questions that dealt with the arc length formula. But let's review a little bit more with converting between degrees and radians, and then also converting from your degrees listed as a decimal to your DMS format, so degrees, minutes, and seconds. Okay, let's split the board into 4 different areas. And we'll do 1, 2, 3, and 4. All right, so let's practice here. We're going to convert from DMS to the decimal form of your degrees. So notice that you are given degrees, minutes, and seconds. Let's change that to just the decimal form of your degrees. So pick 1 or 2 to work on. When you have an answer, put it in the space provided, and I'll be sure to check the work. Once all of them once all of them have been answered, we'll go through those. Oh, good. And these are bringing up a good point that I didn't mention before. Number 3, I noticed that a little bit of rounding was done. When we're converting to the decimal form from DMS, we do not want to round. Because if we do round, we won't be able to convert back to DMS appropriately. So with these type of questions, we want to actually leave the full decimal that we get. So some of these decimals might be a little bit more lengthy, but we do want to leave them intact because if we need to switch back to the DMS format, we can do so without running into any errors. Okay, so I'm just going to get rid of that 118.74 because that one's the rounded one. Okay, looking at these, they all look good though, so don't forget that to convert the minutes, you're going to do over 60, and to convert the seconds, you're putting it over 3,600. So for all of these, that first part should be over 60, and then if there is a seconds part, that can be over your 3,600. All right, everything looks good here though. Any questions with converting to your decimal form if you're given the DMS? In question 3 here, yeah, so if I take a look at question 3, we should have 118 plus 44 over 60 plus 15 over 3,600. So I'm just going to bring my calculator up real fast. As you're typing these into your calculator, don't forget to put parentheses around your fractions. if you forget to do that, it's not, the order of operations aren't going to be done correctly. And the calculator won't give you that correct decimal. So yep, it looks like the seconds were added in there. So 118.7375. So that looks good. Good. Any other questions? Okay, let me break the board up into 4 more sections, and I'll label them 5 through 8 this time. Now let's go the other way around. Can you take that decimal form and convert it to DMS? So remember, that involves multiplying by 60 a few times. When you have an answer, go ahead and throw it on the board. Who's got the alt code for the degree sign? Is it alt 0178 or 2178? I used to have it memorized. Alt 248. Okay, so the degree sign, to type that on a computer, is Alt 248. Ooh, that gave a division sign. Let's see. Oh, I got it. It worked. The minutes and seconds are on the keyboard already. It's just by your enter sign. That's weird, Isaias. Do you have a school laptop or your own? Okay, that's probably why. Maybe your keyboard or motherboard or whatever it's called is set up different. Who knows? I think I used to use, let me see. No. I thought I had like a different alt code, but I can't remember it now. All right, we got a couple of responses. We're still waiting on 8. I'm going to take a look at question 5. So 21 degrees, 12 seconds, minutes, sorry. Don't forget the little marking there for the minutes. If we do 0.2 times 60, that gives us the 12. And because we don't have a decimal there after the 12, we would just stop at 21 degrees, 12 minutes. In 6, I think we have an extra 0 that's not needed. Let's see, we have 0.7 times 60. 0.7 times 60, I believe, is a 42. So let's take away that extra 0 at the end there. So it's 49 degrees, 42 minutes. Notice there's no decimal there either, so we do not need to worry about any seconds in question 6. Question 7, we're taking a 0.32 and multiplying that by 60. So that's a 19.2. So the 19 minutes looks good in the problem. Let's take the 0.2 and multiply that by 60 to figure out our seconds. And that should be 12 seconds. So question 7 looks good. Question 8, we got 2 people with the same answer, so that's always good. So let's start with the 0.37 times 60. That gives us a 22.2. So 0.2 times 60, we already saw in that last one, we're going to get 12 again. So 22 minutes, 12 seconds. Perfect. Questions with converting that to your DMS format? Okay. Let's go ahead and see if we can convert these from DMS to radians. Notice that some of these may have to be changed to that decimal format before you can convert it to your radian. So I think 15 and 16 actually need to be converted to the format that you see in 13 and 14 before you can actually convert that to your radian. So keep that in mind when we get down to those last 2 questions. Let's split the board up into 8 different parts here. When you have an answer, go ahead and put it in the space provided. Okay, and I went and converted 15 and 16 to that decimal form. So 61.4 degrees and 75.5. So for these, because we are working with degrees, we want to use this ratio, right? The degrees is going to be on the bottom. So we're multiplying by that pi over 180 and reducing when possible. For 13 through 16, because you're dealing with decimals, there's probably not going to be a good reduction for that fraction. So if you want to put them as a decimal answer and put radians after, you can do that. For example, in 13, we would set that up as a 71.72 pi over 180. Well, that doesn't reduce very well after that fact. So if I want to change this, I can go ahead and make sure I do 71.72 pi divided by 180. Now I did put parentheses around the 71.72 pi in that numerator before dividing by the 180, just so my calculator knows that that's all in the numerator of my fraction. I think it'll still work out without it though, but just to be safe, I did that. When I change that into a decimal, you get about 1.25 radians there. So if you wanted to, you could convert that down to a 1.25. Look at you guys go. For 14, I got 0.206, but let's check it out. 11.83 pi divided by 180, 0.206. So I'm just going to add a 2 in front of or right after that decimal. There we go. That looks good. All right, now that we went through those, any questions with converting your degrees to radians? Okay, and we don't have time for it, but you can go ahead and do the other way around. So you can convert your radians to degrees. Make sure when you do that, you're using your 180 over pi this time, because you want the pi's to cancel out from the top and bottom. All right, we won't go through these because we don't have time for them today, but check it out in your textbook, in those practice area. So the review questions there before going to your homework. But if you feel comfortable, you should be all set for that 4.01 homework assignment. All right, any questions before I let you go today?